Okay, I'm going to prove the area of a circle. Okay, now suppose I'm going to draw an axis. Yeah, it's not perfect. Yeah. Let's say we have some radius r out here. Doesn't really matter. It could be any number. It could be 2. It could be 3. It's a and okay, so now I need to write a function of this. So what is my function gonna be? Now it is centered at the origin. And if we're going polar mode, we have the general form x plus y squared equal to r squared. What we can do is move the x squared by subtracting it from both sides. We get r minus x squared, and then we can take the square root. But we get two answers, plus or minus square root of r squared minus x squared. Now, and we want to find the whole area of this circle. What do we do now? If you know calculus, you know the integral. So we're going to find a, which is going to be, so what I'm going to do, I'm going to simplify a little thing. I'm just going to find the area of one quadrant and multiply it by 4. So 4 times the integral, and our bounds is going to be from 0 to r. And of course, and I forgot to mention, this is y equals the positive, this is the negative. Because it's not a one-to-one function, it fails the horizontal line test. Even just the positive. So we're going to integrate a root r squared minus x squared dx. Now, how can I evaluate this? Well, here's what I'm going to do. I will make a substitution and see if I can simplify some things. Let's let x be equal to r sine of theta. And then now we can take care of that. Now let's take care of our dx. So dx is going to be r cosine of theta d theta. So this is going to be 4 times, and now we're changing from x to theta. So now we still have our square root, r squared minus I know I sound like I'm skipping steps, but basically it is this r squared minus this whole quantity squared. So it would be r squared sine squared, and then we have our dx times r, that's on the outside of the square root, don't forget that, cosine theta d theta. Now we got to change our bounds. So where we plugged in 0, x goes from 0 to r. We can stay in the theta world if we want to, so I'm going to do that. If you go in 0, where's 0 is equal to sine theta, or sine theta equals 0. We're going to say theta will start at 0, and we plug in r. Of course, r is our sine theta, or sine theta will be 1. And we're going to say theta stops at pi over 2. If you remember your unit circle, so this is where pi over 2 would be. Or where the sine is 1, so it would be at this point. And the sine of what will give you 1? Pi over 2. So that's where I'm getting this from. So now let's try and simplify this a little bit. At 1 times r d theta, and now we get 4 . Of course, we can split these apart. And this, I'm going to write this in a different color so you can see. This will be, is really cosine squared theta. And we're taking the square root of it, so we're going to have, and we got an r. So what's really going on here? Square root of r squared, it's going to be an, so we have, and we got another r. So we have r squared cosine squared theta d theta. And I can't easily integrate that. And I also remember a trig identity. I'm just going to make a note over here. It's equal to 1/2 1 plus cosine of 2 theta. So we're going to apply this. And since the r squared is also a constant, we can pull that out. And since we're also getting a 1/2, we can also pull that out too. So we can also, that's 0 to pi over 2, 1 plus cosine of 2 theta d theta. And of course, 4 over 2 is 2. And we can easily integrate this now. So we got 2r squared. And we're in the theta world. Theta. Here, you would do a quick little u sub. Let u be 2 theta. And then du would be 2 d theta. So what happens is we would get, and then we'd isolate the d theta, which is just du over. So we end up with 1/2 cosine u, and the antiderivative of cosine is sine of 2 theta. But we also have a 1/2 on the front. Don't believe me? You just take the derivative of it and you get cosine 2 theta. And we evaluate this from 0 to pi over 2. So we get 2r squared pi over 2 plus 1/2 sine of pi. Pi over 2 times 2 is just pi. Subtract minus 0 plus 1/2 sine of 0. And what's sine of pi? And if you look on, we'll use this as a unit circle, but pi lands here. Of course, you go -1, 0. So sine of pi is just 0. And sine of 0 sine of 0, 0 degrees, is just 0. So really, this whole term is 0. And what we get is really nice. We get 2r squared times pi over 2 the 2's cancel, and we get a nice pi r squared as our final answer. And we're done.